The box is at the top of an inclined plane. There is no friction along the inclined plane this way, and there's no friction on the incline of the flat plane here. So the block will then slide down the incline, slide on the flat surface, and become a horizontal projectile. It'll then launch itself somewhere to the ground. Our job is to figure out how far in the x direction this block goes. But we're going to write our answers in terms of h and any other universal constants. Okay, that would be useful. So it looks like we have two parts. We have an inclined plane and then a horizontal projectile. Probably the easiest way to do the inclined plane is with energy. So it's at the top at rest, so we're going to say we have no kinetic energy initially, but there is gravitational potential energy. There's no work done or no springs attached, so it looks to me like all we have is gravitational potential. At the bottom, when the block reaches this position here, I'll just draw it here at this place right here. It looks to me like we will then have kinetic energy, but let's decide where we want our origin. Let's say we put our origin at this location, this level, then there would be no gravitational potential at that point if that's where we place our origin. So we have kinetic, there's no friction, so no thermal energy, and again, no springs attached, so there's no elastic potential energy. So it looks to me like we have a simple gravitational potential energy going to kinetic energy. So that, of course, would be mgh equals 1/2 mv squared. Now what I want to do is find the velocity here because we will be launching it horizontally with an unknown velocity. So we need to find out what that velocity is for the second part, which is your horizontal projectile. Let's see what we can do. Well, masses can cross off here, and then we can solve for the velocity. Velocity then is going to equal the square root. I'll take the 2 to the other side, so that'll be 2gh. So remember, we're dividing by half, which is the same thing as then multiplying the other side by 2. So the launch velocity here is going to equal the square root of 2gh. Okay, so that takes care of the first part. Second part, we do have a horizontal projectile. So our job is to figure out how far in the x direction it goes. So let's do what we always do. Let's do y direction. Okay, so we're going to start off with our beginning velocity in the y is going to equal 0, because remember, this is an x direction launch velocity. There is no velocity, or the velocity is 0 in the y direction initially. v2 is a question mark, and I'll just put a little dash line to that because we know we're not going to need that one. Acceleration is going to equal minus g, your negative 9.8 meters per second squared. Displacement is going to be minus 2h. It's going to go down a value of 2h. Okay, and time, of course, is a question mark. Now that's what we're going to solve for. If you remember from projectile motion, really we have a y direction and x direction. They have nothing to do with each other, but they are bound by time. So once I find the time for this, then I can use d equals vt in the x direction to figure out how far in the x direction it goes. So I'm going to use d equals v1t plus 1/2 at squared. That'll be my equation. This, of course, is going to be a 0 because we do have a 0 beginning velocity there, so I'm not going to include that in my answer. Okay, so my distance that falls is minus 2h. That's going to equal 1/2 a negative g times t squared. Okay, then it's just a matter of solving for it. I'm going to take the 2 to the other side, and I'll take a negative of all that and then square root. So it looks to me like the time it takes to fall is then going to be a 4h and then divided by g, and then I need to square root that. Okay, so my answer is close to being done. My time in terms of h and g, I've got a velocity in terms of g and h. So then I know in the x direction, so I'll just write x here. X, the only useful equation, d equals vt. So I'm going to multiply these two then to get my displacement. Displacement is equal to the square root of 2gh. Multiply that by the square root of 4h divided by g. Now remember, you can think of this as just one big long square root. Okay, my g's will then cancel out, and I'll have 8h, 8h squared. Okay, and then I'm going to take the square root of h squared, and I will also take the square root of 8, and then we actually get 2 square root of 2 times h as what displacement equals when you're done with that. And if you're not sure how to do that, do that yourself. Get your steps together, cross off your g's. You've got 4 times 2 is 8, and then h squared. The square root of 8 is 2 square root of 2, and the square root of h squared is h.